name is Mark Quinsland. This doesn't need to be recorded. My name is Mark Quinsland. I'm a field engineer with NEO. I've been there for about 5 years now, and before that I worked in a similar role with DataStax Graph, and I have the best job in the world. I really love my job. And we are hiring, by the way. We're always looking for really talented people. But I'm a field engineer, so I go out to work with different companies implementing projects. For those of us that have like limited attention spans, I mean, being able to work on all these cool projects is really just heaven for us. I mean, really interesting projects. But before I did that, for about 15 years, I designed technical search engines for car companies. And it's kind of a niche, I know, and I thought that there's never going to be any benefit to it, but it turns out that it's actually pretty useful. So I introduced a lot of technologies to car companies all over the world. I still have a lot of stuff running in Japan, in Germany, China, France, Italy, Detroit, a lot of different places around the world. And what I'm going to show you today is a project that's based on some of that early work. So, but anyway, it's useful stuff. I'm working with a partner in Japan at a big car company. I can't say which one, but if you go to the link, you'll notice that it actually has the company name in the link, but I'm not allowed to say that. So I just, so if you pay attention to the link, then you'll see which one it is. But a couple more minutes. Making cars is really pretty difficult to do. It's unbelievably complex. And right now, supply chain issues and everything, there's a lot of issues going on with what's going on with automobiles. We haven't got started yet. We're just kind of doing I'm warming up the crowd. So, but it's pretty complicated. There's a lot of stuff that's involved, and right now is even worse because you've got people that are converting from internal combustion engines over to EVs. And so the infrastructure is not there. The battery technology is in so much flux, and being able to design stuff and get it out to market is really pretty critical. And I learned along the way when we were designing a project for Toyota, and the guy said, look, every day that I could save from them was going to be worth like between $200,000 and $350,000. So if we could like get this product to market. And that was like 20 years ago. And the complexities change and the stakes are a lot higher. So being able to safely get a car out there with all of the complexity, it's really involved. And so they tried doing it using MySQL, they tried using SAP and Oracle and all that stuff. And then I came along, showed them how Graph works, and it's really, really working well. So we'll get to that. Okay, let me know when you're going to start. We good? All right. Good. Okay, so welcome to the final session for the day. These are some real-world examples of Graph being used in automotive and some manufacturing things. There's some real data in here. There's some projects that they're identified with real names. Again, non-disclosure. I can only talk about like Volvo and use their name, but everybody else is pretty much not. There's some material in here from my partner in Japan, Kawada-san. He had originally set to come here, but travel restrictions of COVID, he couldn't do that. We had some technical difficulties, so I'm going to go through his slides rather than but there's a link to it if you want to get his input on it. Few things, and we were out there for a reason. So NEO's really changed in the last 5 years since I've been there. But three of the top 5 airplane manufacturers. I mean, manufacturing a jet is also pretty complicated. So being able to get that done with the amount of trust that's involved is just phenomenal. And 8 of the world's top 10 OEMs for automotive use us in various capacities. Some use us a little bit, some use us a lot, and it's growing in all of these different use cases. And I just like this one because all of the nation's top banks all is a really cool word when you're trying to explain to management. Like, you can trust this technology. That's really kind of what it's about. The rest is stuff you've already seen before. Okay, bringing things to customers, manufacturing. So I threw this slide in. You guys saw this presentation this morning. Emil picked it as part of the keynote because of the importance in a lot. I mean, but being able to trust the distribution process, being able to trust you're getting these things out there. I mean, there's so much politics involved in the vaccines anyway. So any little thing going wrong was just going to mess it up. So they trusted NEO for being able to see what's our supply chain, what are these processes. And they used a lot of ideas that we've already implemented for other companies. So they were really pretty successful with it. Notice they didn't talk much about it. They just kind of talked about the effects of it. But the actual mechanics, well, we'll talk about some of those today. But it's for real. I mean, manufacturing, being able to get this done quickly, effectively, in a way that people can trust, means being able to work with newer tools where the old ones just don't make it. So we'll talk about some of the key things that are unique to manufacturing, but manufacturers are HR companies. They buy things, they hire people, they fire people, they train people, they do all kinds of things. They have logistics. So those are pretty common. And fraud, being able to worry about cybersecurity. So those are some of the other things that we'll look at real quickly. But our top one, really, that's automotive or manufacturing specific, is this digital twin and bill of materials. So there have been a bunch of presentations here this week on digital twins. So I don't really want to run too much into that. But graphs are digital twins, and digital twins are graphs, being able to represent something as being able to say, hey, this is what my product consists of. This is how it works, and there's so many different ways of representing it. The graphs are really pretty useful for stitching them together. But also product lifecycle and validation management. I see it here and I see it here, but I don't see it. Okay, good. Maybe I should stop stepping on this cable. I'll just be careful. Okay, so product lifecycle, that's kind of what the Japanese use cases is, and we'll be talking about that. But supply chain risk and dependencies, being able to analyze what your dependencies are and what your risks are. So graphs are really good at being able to apply theory to figuring out where are my risks. Like statistically, which ones are vulnerable? Where are my vulnerabilities? So when you get into the machine learning and the graph algorithms, being able to look at that and take all of the data in context to say, okay, based upon not just the product information, but the suppliers and their customers and where are they getting them. And so being able to look several hops out and take all of that into consideration when you're looking for vulnerabilities. Root cause analysis, that's a big Boeing project or Airbus project that I'll show you in there. And being able to do predictive analytics. I think we have something in here from Michelin. Regulatory compliance, customer 360, that stuff's all pretty common. Software bill of materials. How many of you guys do software BOMs, like do software composition analysis? So like when your boss asks you, hey, are we using log4j anywhere? That kind of stuff. So if you sell to the federal government, you're now required to produce a software bill of materials, like what libraries are you using, and being able to keep track of that, store that, and everything. It's even worse for cars, especially if your car can get like updates. So there's some really interesting projects about how you use graphs for keeping track of vulnerabilities, just because of the complexity of all of the software that's in there. So that's a biggie also. And then warranty analytics, fraud. I mean, it's amazing how many people understand that here's this $60,000 car, and if you can bribe a couple of people down at the dealership, you can get a couple of catalytic converters that you can sell, and especially the ECUs and the new components, the components that are in there for EVs, just unbelievably expensive. So that kind of stuff. And then fraud and human capital management. The reason why graphs work really well for this kind of data, the complex problems that you have, is because graphs are really good at storing different kinds of data. So how many of you have taken like the data modeling class, and you start seeing how to like do a deep level hierarchy? I mean, like if you try to do a recursive join in a regular product hierarchy, and you're looking to see this contains this, contains this, contains this, and you go down more than 5 hops, you kind of blow Neptune out of the water and Cosmos, and it's pretty easy to blow SQL Server up. But you want to start looking at like what's involved in an A380 or a tank, and you start looking, and it's like I might have over 1 million parts, and the parts hierarchy is like might be like 60, 70, 100 levels deep. And being able to do that in a graph that's what graphs do. We like paths like that. So being able to store data in weird fashions like that without pre-designed criteria and pre-done schemas is something that Neo's really pretty good at. Kind of skip this, but digital twins are graphs. I mean, there's a lot of different ways of describing something, but I worked on one of the world's largest Internet of Things applications, and just keeping track of what was in there for like millions of devices and how they were structured together. We couldn't have done it without a graph. It just didn't work. And that was before I joined Neo even. I mean, they really tried hard to not use a graph, and they failed because they were using an inappropriate technology. And then we showed them how graph could be done, but it was too late to save the project. Okay, good. It's back. All right, a few things. So these are published use cases on our blog, so I don't want to spend a lot of time on them. But like for the U.S. Army, the tanks, like you want to send some equipment out to someplace. Now it's like you're trying to see what's involved in a rocket launcher or some of these advanced equipment that they're sending to Ukraine. But there's lots of parts involved. Training is involved. How do you train somebody on how to use it? How do you train them on how to repair it? How do you streamline the repair process so that you don't have to bring out 2 million parts, you only have to bring out 1 million? So how do you keep track of what's in there? Where are you getting it from, and all of that kind of thing? So the Army uses us for that, but I love this project from Caterpillar. So I worked on a knowledge graph for Caterpillar years ago, and we were trying to use Solar, and Solar just wasn't up to the task. It was like an old-fashioned search engine, which was great, but they had so many documents that they were looking at. They were looking at millions of service documents, and so they started applying NLP to it and getting smart about it. So now the data is analyzed, so every time there's a report filed, any kind of service thing, anything coming from the field, anything from an engineer's notes, goes into this huge knowledge graph. So that when somebody calls with a particular problem, it's not just Solar. Say, here are the 10,000 things that you probably are interested in, sorted chronologically. Now it's smarter, so it's really a recommendation engine. So what you're doing is kind of like Google. I mean, if you think about it, when was the last time you went to Google and you had to search more than 2 pages before you found what you're looking for? That's because Google isn't a search engine, it's a recommendation engine. What they're doing is they're taking all this data in context and saying, here are the results we recommend for you. So that's what Caterpillar built using Neo. And the nice thing about this is they're trying to anticipate problems. So it's predictive maintenance. And predictability is one of the hallmarks of where machine learning is going with graphs. I mean, anybody can tell you what happened. But graphs are used when you want to like influence what you want to happen, or predict what's going to happen, or sometimes prevent what you know is going to happen. So it's thinking about the future. It's much more strategic. So they use this for anticipating maintenance, predictive maintenance, and it really gives them a leg up. But those things are massive. I don't know if you can see there's a human standing there, but those things, I mean, if that thing's down for a couple of weeks because you're waiting for a part to be flown in, but if you can predict what's going to be needed and you can have it ready, it's a win-win. And then Lockheed Martin, Customer 360 applied to products, everything about the product. Again, that's where graphs come in because they're pretty flexible for everything that's going on. I picked that one to represent Product 360. We've got some other product and vehicle 360 customers. There's one near my house. I live in the Bay Area. I can't say who, but so they use Neo for a nice product 360 graph. I like this slide here because you put that green box up there for a manager to read, and you just kind of like just sit down. That's a lot of money. But really, what they were using before was just so slow, and trying to do predictive analytics, or like if you solve a problem for like impact analysis, this is connected to this, connected to this, and connected to this. It's easy to do impact analysis going this way here, but being able to come back this way and do root cause analysis. But you have so many variations. But now you're just traversing paths, and so you're looking to see all of the different things that are going on, all of the different options. So having all of the context of a knowledge graph allows you to, it's like, did you evaluate this? Did you evaluate this? What about this? And say, hey, did you guys notice whenever this thing happens over here, it's like a water balloon. It comes out over here. And being able to track these kinds of problems is what they were able to do. But yeah, millions of euros is a pretty popular thing with managers. This is what their bill of materials look like. You don't, there's not really anything too critical in here, except the structure of this is pretty typical. So they're using Team Center like everybody else does for the bill of materials in manufacturing. We don't want to replace that. They solve a lot of problems. So you're grabbing data from all of these different systems, all of the parts and all of this. So there's different kinds of bill of materials, whether it's engineering or manufacturing or as-built or design. There's all kinds of things that kind of go into this, but they're pulling in as many different sources of data so they can compare, hey, this was designed this way here. I want to see every approval for any kind of variation along the way. Because I need to know why this thing here is vibrating now, because I can't release it until I figure out what that vibration is. So their bill of materials isn't too different from the other ones. It's something that they're very successful with, and that's probably the most they're going to talk about it in public. This one here, on the other hand, Volvo, they love Neo. This is actually from Graph Connect, one of these presentations 3 years ago. And they got up there and they talked about, this is what we're doing. They had this crawl, walk, run approach. So they were crawling. They did a couple of these things, and that's what their goals were, to do these things here, reveal dependencies, but really they wanted to just leverage their existing data. And they started small, and they were just in our office a couple of weeks ago and say, hey, cool, what's new with Neo? Because we're trying to do this thing here. I mean, they sent like 7 people to San Mateo to like, okay, here's what we're going to be doing going forward. So they really like Neo, but this is a great knowledge graph. And there's a presentation down here, and there's some YouTube videos if you want to see what they're doing with it. But they're trying to transition from the old style cars. They still have to build those, and they have to maintain those for a long time, but they've also got like the electronic versions of Volvos that are out there. We're a good Swedish company, we like working with them. But Volvos are probably the most vocal. There's another project in here I'll talk about in a minute. This was pretty easy. They actually published some stuff of what they're doing, and there's a link to it here on the video. But so Michelin is trying to do predictive analytics, figuring out what's going to happen when. So they do a lot of, it's not just tires, they do a lot of stuff on the drive line, a lot of brakes. And being able to figure out what's happening with these components, which ones are failing, especially now with the supply chain stuff, because there's so much like, I can't get this part. Is this one almost as good, or is it better, or is it cheaper? Can I get it? Where can I get it from? How do I test it? Where is that being used? So being able to not only have better products, but have better information so that you can notify people ahead of time. And I mean, the goal is really not just to find problems, but to find problems and be able to give back the information in a format that they can that's actionable. So this is represents one of our project or one of our customers in Europe. I can't say the name. But it's called they supply parts to a lot of different car makers. So this is really a problem for them, because like if I've got all these different parts that are used in all of these different models by all of these different people, and something's not available, or say I can't get an analog brake system from Bosch, I need to get it from Siemens, but Siemens has a different flashware version. So you start looking to see, okay, have I tested it with this? Can I test it with this? Is it going to be reliable? I mean, you're going to find out what happens when you use this stuff, but you should probably find out about it before your customer does, before the newspapers find it, oh, that was the reason this car crashed, kind of thing. So you're trying to, the validation process is unbelievably critical. And so when you're looking at the complexity of some of the relationships, this is just like trying to do this the old-fashioned way of, oh, I think it's this one here. You know, that just doesn't work. So being able to statistically identify what should I pay attention to is really critical. So this is actually, I had to fudge everything, but it's real data, but it's just kind of, everything's called part 1, 2, 3, and so on. But yeah, it's complicated. So this is, again, so we'll look at some of the machine learning or some of the graph algorithm tools that they're using to try to make it simpler. Okay, this one here, this is, again, I can't present it, but this is something I wrote a search engine about 10 years ago, technical data for this big Japanese car maker who has operations in the Midwest. And so it took me 4 years to land that deal. They were unbelievably conservative and like, please show me this and show me this. 4 years to land a deal. So I don't know how many of you have done sales before, but 4 years, it's a long time. So anyway, so I designed this application for them and then I changed careers. But I gave it to some friends of mine who were running a software consultancy. They took it and ran with it. That customer is their best customer for the last 10 years. They have like 200 employees now based upon just servicing that account. And so when I started with Neo, I said, hey, that stuff we wrote with Solar and Mongo, oh man, I apologize for doing it that way because it just didn't work very well. It was good at the time, but it was like a 2000 search engine. So I showed them how to redo it with Graph, and they took it and ran with it, and so we kind of helped them. So I've been working on this project for about 10 years. Off and on. So the company's name is EASYS, and they're in India, but what it does is there's all these different domains, and building a car is really difficult. So you've got like context information from all these different systems, and you know, like you're dealing with like, why are you doing this car? What country is it for? What the project management, all of the business aspects of it, the regulatory considerations. I mean, cars, anybody ever drive cars in another country, like on another continent? They're, you know, they don't typically have big, like, if you see a Hummer in Germany, or in Japan, it's like, you'll never forget, it's like, oh my God, it looks like Godzilla, it's so big. It's just out of the thing, but you're dealing with all of these different processes and all of this different kinds of data from different systems, you know, crash tests, and, you know, you may make a change here, but it affects the vibration that shows up over here. So you make it stiffer over here, but now maybe you've weakened it in a crash test, or now it makes too much noise, or now the door doesn't close all the way, or somebody makes a design. So all these people have to work together very carefully to know what each of them are doing. So that's what this project was designed to do. Again, this is a company called EASYS. They're in Japan and in India. So you're taking all this data from all these different sites, and you're like, how do I manage all of this? Because I have a lot of testing I have to do before you can put out a car. Emissions test, noise test, durability tests, and you have all these different stuff. And what you're trying to do is you're trying to do it as early in the process as possible. So if you can do this with math and just do it with simulated data, then you're much better off. So being able to take existing test data, run it through some machine learning processes so you can reuse it for simulation. So you do some simulation, you make a decision, do some more simulation. Maybe you need to do something physical. So it starts off with really pretty basic analysis, and it works its way down. You try not to spend all of your resources on every possible combination. There's just, again, you saw the diagram, it's horribly complicated. Oops. So like if you've got all these different countries, each with their own characteristics of making the parts, making all of the things, and multiply that by the number of models that you have, and then you start looking at the components that are inside it. So a typical car might have like over 100 ECUs now. It might have between 25 and maybe 50,000 parts. that you're keeping track of. And so these are from different suppliers. These are the different parts. Now you have all these different kinds of tests that you have to run for each of these kinds of things. And if the test fails, then you have to do this, and you have to notify all these other people. But you start with this big design process, and it goes through all of these different things for, marketing gets involved, legal gets involved, the government gets involved, regulatory agencies, and everybody's getting their fingers in there, and you have to have some way of communicating this and finding the results. So you're putting all this data out there, and now you need a knowledge graph so I can find it or find similar things. Because hopefully you can reuse your data. So your search engine has to be good. All these different things. But by going across the bottom there, you're trying to find the problem as early in that step as possible. Finding it while you're doing the math and you're doing the engineering that something is out of compliance, that's the best time to find it. Once the cars are already on the road, that's really expensive. Now you're doing recalls and stuff like that. So if you can find a problem and fix it in the hardware in a loop, or even just doing it on a test bench or doing it on some kind of field test. So it gets unbelievably expensive. And every time you do those things, it costs a lot of money. So being able to shave off like a month off of like an ECU calibration or something like that is really worth millions of dollars to the car companies. Per car, per market, everything. I mean, there's billions of dollars at stake when they do this. And this is what the user interface looks like. I apologize for that. Again, it was a lot of this is based on what I did a long time ago. So it kind of looks like a 1990s search engine, but it's really powerful under the hood for what it can do. But being able to find the data, now they're starting to use the graphical user interface. Introducing graphs to a conservative organization is not easy. I'll just be flat out. It's not. People love rows and columns. They love Tableau. They love Excel. It's kind of like one of those things when, the end of the world and we've had nuclear holocaust. The only things that are going to survive are cockroaches and Excel. I mean, it's there. People like rows and columns, and I lobbied against this and I lost. So anyway, but some people like the capabilities that the graph brings them. What the graph brings is the ability to really extend your thing. Most of the time they thought they were dealing with this area over here, the measurement data over there, where there's a little bit of information there, but why are you doing this? What mark is it for? Can I reuse this kind of stuff? Why do we have? So this is what makes it a knowledge graph, is because now I have this information that I really need for the engineers, but I also have the business information. So now it has context to it. And that's the whole point, is being able to, so I might do a query that instead of doing a solar query where I've got this really stupidly simple solar document that I'm searching for, I might do a search that involves 30 hops against all these different types of, go find me that has this and this and this and this and this and this. These filtering things can be several hops out. So it makes it very easy to find, or time-based, and say, but show me all of the changes for this kind of thing that were approved by that department for this kind of model during these years. And it might be millions of things that it slogs through. So but they've done it for, so now this is like for all of their operations in Japan, and now they're moving it hopefully to the US. But the data model, this is based on a model that I'm pretty familiar with. We helped develop it for this German standards organization. So being able to, it's kind of blurry for a reason. I mean, we don't really go into detail unless you really are interested. But we can kind of go through and what's in there and how it works. And then there's a video available on what's involved. But one of the samples there is like, so I've got this test I need to design, so I've got business information. The nodes that in the graph that represent the business context, those subject matter experts, and they were thrilled that they were being asked, because usually there's this divide between what's available. I mean, like usually when you're working as an engineer, you're working from this engineering database, and the fact that the engineers have access to the same stuff that the warranty people have access to, and the same thing that the business analysts or the strategy engineers have access to. So each of these things are major groups of people that all need to do this coordination for being able to run these tests, be able to do them. And again, so my expertise was mostly in the measurement area and keeping track of the stuff that's in there. And we were just dying because we had just like a small part of the BOM, and being able to extend it to the business information. Why is this information there? the graph really brought so many capabilities, and that's really what drove the deal. Same thing there. So this is kind of a replay of that, but you've got all this kind of information that needs to be shared. And the whole point about manufacturing quality is being able to share. I think that was the main point that he had this morning, was being able to share this information. Where is this? And I need to be able to get actionable information to the people that are working in order to get their vaccines out in time and the medicines that we're talking about. So being able to communicate this stuff is the whole point of the knowledge graph. And being able to look at it from different points of view. So a graph might have multiple entry points based upon what the source of data is. Could be coming from a BOM, could be coming from warranty stuff, could be coming from lots of different things. But if you design your graph well, being able to extend it with new kinds of data types and new types of relationships, that's what we do. So that's why Volvo started small, and they could just keep adding to it. They could just keep adding more and more functionality to it. And that's kind of what the work surface looks like, being able to run some kinds of tests and being able to like pull up a test. And I mean, it's a real problem. My first, just checking on time. Is it really 5:15? What time do I go to, 5:30? Yes. Okay, I'll go quick. All right. Okay, so I'll have this link in here. This is for the actual, there's a video that went along with this, and I apologize that we couldn't get it working out to where Kawada-san could present it. Got a couple of other graph use cases that are in there. This is very similar to what was in there for Pfizer this morning. So Boston Scientific, keeping track, making sure that the equipment is manufactured to, their reputation's on every device that goes out there, being able to test and make sure that this stuff works. Where are they getting the parts from? Like, is this batch of rubber going to contaminate stuff? And so being able to identify this, especially alternatives, was really critical. And they're using Aura for this. They'd rather be designing devices than trying to maintain equipment. Customer 360, we talked about that. This is a little bit different. I talked about software bombs and being able to see what's out there. So this is a big problem. There's so much software in cars. It's unbelievable. Like I've got a plug-in hybrid, and it's probably got 1 million lines of code in it. Just being able to keep track of stuff. And all of the stuff that's in your cars. Well, so this is a tool from Lyft that they came out with. It's really pretty useful for just keeping track of what software you're using, because a lot of the software, when it gets deployed in a car, and now anybody that's delivering stuff that can be hacked needs to be really careful about what kinds of stuff goes out there. Like hacking devices, it's trivial to hack a toaster. I mean, my son, he's like, oh, watch this, kind of thing. But if you can start or stop a car, and you can, being able to download some information to it, or being able to like man-in-the-middle attacks, so there's processes that are out there for keeping track of the software that's in a car. There's like United Nations international regulations for keeping track of what software is in that car, who's allowed to update the software that's in the car. So the analog brake stuff, or the passenger restraint, or all of the other software in the car has to be kept track of in a software bomb. Okay, and then last but not least, Daimler. They love us but they realize that people are not machines. I mean, like the classic hierarchy of things. And so they, it kills me, because Daimler was one of my best customers for like 15 years, and they're so slow about like graphs. I don't know, but graphs for HR, they love it for keeping track of the relationships. But in manufacturing, like keeping track of who needs training and who needs devices and that kind of stuff is really who works with who, how are the teams together, like actual working things. Not that Vic works here and Mark works for him, Mark works with Alex over there, and Kent, and all of these other formal relationships. You've got like lots of informal relationships and projects, and especially with keeping things, and you can start noticing who's having issues. So, but that's that's that one there. I'm going to skip through a couple of these real quick. So some graph analytics, these are used quite a bit for being able to just figure out, so we apply some of the things from our graph algorithms, and I'm going to go ahead and I'll show you that real quick. But like visually exploring, so like that big mess ball that I showed you, that big hair ball, so what I did was I ran over here, scoot down to that. I went over to our graph data science playground, and I ran an algorithm. I'll show you how I did that. It's really pretty simple. I fired this up. I'm going to run PageRank on like components. I'll run PageRank on components. I'm just going to use relation type of. How many have used the graph data science library in any way, or had heard of it before? No? Okay. All right. So I'm just going to run some really simple ones, undirected, and run the algorithm. I don't know if you can see that. So anyway, I quickly calculated the score. This is like the Julia Child show. I did this while I was waiting outside, so the results are already in the database. I could have saved the results. So now I know what the page rank is. So based upon that, I can kind of focus on that. There's a bunch of other algorithms that are there. I mean, you know, if you like some of the choices that are available, pretty easy to just run them from here. And the nice thing is, it's kind of like a wizard. It'll step you through it, and then you go in there and tweak your stuff, and it's a lot easier to just tweak it. And now I found out that's even easier because you can just run it from Bloom. So, it's like I learned something at these two. All right, so I've run that, and now if I go over to Bloom, and let's get rid of that. Okay, and if I want to see what the impact is of that, so I'm just going to see impact of the top component using PageRank and press enter. So this is based upon that. So to go grab the most important one, where should I focus my efforts? Based upon that, then let's look at it, hierarchical layout. So it's saying that this part right here is used in these models. Trust me, there's the part there. It's got models. It's pointing on.
Oh, there it is.
Yeah. So being able to say, oh, okay, how is this, like where is this thing being laid out? And it's like stupidly simple to be able to run these and identify statistical interesting things, and whether that's you're looking for fraud. I mean, a lot of times this one manufacturer was found out that a lot of their claims were because they were using counterfeit parts. I mean, just like how many of you have ever heard of the issue of counterfeit parts in manufacturing? I mean, it's real. I mean, you have to. There's an awful lot of really crappy stuff out there. Just being able to identify what it is, and so you're looking for statistical anomalies. Graphs can help you find them. It's a really wild. It's a really popular topic right now with the digital twins and stuff. But I'll give you the. I'm standing between you and we have a couple minutes for questions too. But you and Obeer 30 is coming up. So just being able to like figure these things out, like supply chain. I was in Seattle, Washington, and there were a bunch of people from a big airplane company up there. And so the guy is like, he's so unimpressed. You know, he's just like, you know, and I used to be an Oracle DBA, so you know, he's going to play that card. And I'm like, no, don't play the card. So I kind of challenged him, said, okay, you are a manager. You work up here, and this person works for you, and this person works for them, and this person works for them, this person works for them, and then you all go down to my level down here. So all these people down here, all these levels of hierarchy, we are working on things for this airplane. I've got different projects, and this project has parts and has components and components and components. These things have to be tested, and you've got a testing hierarchy that includes this, this, and this, and this. So I've got 3 different hierarchies that I have to do recursively. I said, if you can write that in SQL, I'll buy you dinner tonight. And he just, like this. And so then I showed him like 4 lines of cipher code. And that was what it took. He was like, and it's not whether you're smart, it's working smart. You know, you're having really good tools and being able to do recursive relationships. Like this query here is basically, let's go into Cipher, like this one is, this one here. This is what the query looks like. I mean, really, it's basically go find this component here that's ordered by page rank, and then go find the hierarchy from this up to 6. So get this component as part of relationship up to 6 levels deep, connected to, well, part of, which means it's going to be parts. If I want to make it directional or remove the direction, I just go like this, and now it's like I either, these consist of me or I use them kind of thing. So like what's under the hood? So that's how difficult it is to change. So I change that query there, over here, and let's clear the scene. Demo guys already got Mike this morning, so they're not going to get me, but all right. Takes a little longer because now it's working both ways, and I didn't refresh the database, and so there's nothing in cache, so the query's going to run slow, so maybe the demo god will get me. But I think it's also going to just generate, because it's 6 levels deep, and it's going to be just there's a technical term for it, but it's going to generate probably my entire data. Six levels deep, and in this database is probably going to be bringing back a few million things. So okay, maybe I don't want to show this one. So, and that's kind of the other thing. So like going back to that picture of the hairball, there's just so much stuff that's out there. I mean, so being able to use any kind of like graph algorithms for figuring out what's statistically interesting, like which steps along my path, being able to do path analytics are really pretty important. Being able to do community detection, so you start looking to see what are the similarities, and like identifying how is this thing similar to. It's not so common in manufacturing, but it does a lot with your customers when you're looking to see purchasing personas and how are they doing things, or when you're looking for fighting fraudulent activities or anything else in your organization. So community detection is not so common, but path analytics is difficult to do if you're writing SQL, but or graphs, we love paths. You want to do a Dijkstra, like traverse a tree through a tree, one line of code, and it's really pretty simple to do, and this thing isn't going to come back. Yeah, let's go with that. It's a local database, but and I also realize, this is also kind of interesting. And so you see I'm running on battery and I'm down to 14%. Because I'm on battery, there's certain features in the hardware that are clicked off right now, so I'm also getting burned by that, so I apologize. Anyway, I think that's all I had. I don't remember. I've changed this presentation like a zillion times over the last few days. Yeah, I definitely brought in like a ton of extra data. I mean, like, yeah. So I'll change that query back, but all right. No, that's pretty much it. Just this guy here, really, this is again, any database can really tell you what happened. I mean, well, hopefully. At least they don't drop the ball on that. But being able to predict what you want to have happen. So most of the use cases that I showed up there are really the things that are geared towards more strategic things. But like you're trying to influence somebody's behavior. So which is why you're doing recommendation engines. But anytime you have a search thing on your functionality that you're delivering to your employees, to your coworkers, to your customers, that should be more of a recommendation engine. You're trying to recommend your search results. So being able to recommend things, being able to prevent fraud, prevent breakdowns on the field, product recalls. I mean, how expensive is it to have a product recalled? I mean, you know, if it's like other than the hit you take when, like the Chevy Bolt, you know, like don't park it in the garage because they catch on fire. You know, that's kind of an expensive thing that probably there's a lot of reasons why that could have been, but better testing could have probably discovered that. So you're trying to discover problems early before they get really expensive. I mean, software is not always the problem, but even in software, you find the answer to something, you find an improvement to it, but you might already have a bunch of processes in place that use it. So again, graphs, doing the simulation in graphs, being able to like simulate something using a digital twin to figure out, learn ahead of time what's going to happen. So again, anything you can do for impact analysis, what's going to happen when I take this thing out here. So the smart manufacturers are using it already. Volvo loves it. A bunch of other companies use it that I can't talk about. But again, it's not rocket science. Just use the best tools that are out there. And we love helping. So if you have any kind of questions like that, I put my email on the thing for that. And that's me, Mark Quinsland. Yeah, give us a ring. You guys have any questions? Cool. All right. Thanks for coming.